military technologies that have reached a new level. How advanced systems are redefining safety, mobility, and modern warfare. Modern military technology is no longer just about raw firepower. Today, innovation is driven by precision, protection, automation, and the ability to reduce risk to human life. Across land, air, sea, and cyberspace, next-generation systems are being designed to act as extensions of human capability, seeing farther, reacting faster, and operating in environments that would otherwise be too dangerous for people. From robotic vehicles that enter hostile zones before soldiers do, to autonomous aircraft that bridge the gap between drones and helicopters, these technologies represent a fundamental shift in how military and security operations are conducted. What follows is a detailed look at several advanced systems that demonstrate how far modern military engineering has progressed. Multi-purpose anti-terror robotic vehicle, a mobile shield and scout. Among the most striking developments in modern security technology is the multi-purpose anti-terror robotic vehicle designed to support police and military teams during high-risk operations. This system is built to operate where human exposure would be extremely dangerous, effectively acting as an advanced set of eyes, ears, and hands. At the front of the vehicle is a foldable ballistic shield that can work in coordination with a detachable mobile shield, creating a layered defense system. Together, these components offer high-level ballistic protection, allowing the robot to advance into hostile areas while shielding personnel positioned behind it. Situational awareness is one of the system's strongest features. The vehicle is equipped with 9 cameras, providing wide-angle and close-up views from multiple perspectives. 2 onboard LCD screens give operators clear visual feedback, while microphones capture surrounding sound. A built-in megaphone allows communication with suspects or civilians from a safe distance. In addition, high-intensity lighting and disorienting strobe lights can be used to temporarily impair hostile individuals without direct confrontation. Safety monitoring is another key function. The robotic platform carries sensors capable of detecting hazardous substances and measuring oxygen levels, making it especially useful in environments where chemical threats or confined spaces are a concern. One of the system's most practical advantages is its modular tool design. Operators can quickly swap attachments depending on the mission. Available tools include a breaching nose for forced entry, a heavy ram, a gripper for handling suspicious objects, and a telescopic camera for inspecting hard-to-reach areas. This flexibility allows the robot to perform a wide range of tasks without requiring multiple specialized machines. Despite its robust capabilities, the vehicle is designed for transport efficiency. It can be moved on standard trailers and measures roughly 15 feet in length, just over 8 feet in width, and approximately 11 feet in height. Control is maintained remotely from distances of up to 1,600 feet, and the armored body is constructed from Armox 500T steel, known for its strength and resistance to ballistic threats. In real-world scenarios, this robot can be sent ahead to investigate suspicious locations, breach doors, deliver equipment, and transmit live video and audio back to command teams. By doing so, it gives operators valuable time to assess the situation before committing personnel, dramatically reducing risk. Heavy-lift electric aircraft, bridging the gap between drones and helicopters. Another major leap in military and rescue aviation comes in the form of a fully electric, heavy-lift aircraft that functions somewhere between traditional drones and full-size helicopters. This aircraft is designed to carry people or heavy equipment without placing a pilot in harm's way. Capable of traveling approximately 32 miles and cruising at speeds near 53 miles per hour, the aircraft can carry payloads of up to 380 pounds, depending on configuration. Its large frame spans about 25.5 feet, supported by oversized propellers measuring just over 7 feet in diameter. The motivation behind this design is simple but powerful. Small drones lack the lifting capacity required for meaningful transport, while helicopters are expensive, slower to deploy, and expose crew members to significant risk. This aircraft fills that operational gap by offering rapid deployment, reduced cost, and unmanned operation. Developed by MAV'RX, the system is frequently discussed in the context of rescue operations and medical evacuation. In emergency situations, minutes matter. The ability to extract an injured person quickly, without risking a pilot's life, can be the difference between survival and tragedy. Because the aircraft is uncrewed, it can operate in dangerous environments such as combat zones, disaster areas, or unstable terrain, extending the reach of rescue teams while minimizing exposure. Hybrid robotic carrier, endurance, power, and quiet mobility. Developed under the U.S. SMMET program, this robotic carrier represents a new class of unmanned ground support vehicles. Designed to assist troops by carrying equipment, supplying power, and navigating difficult terrain, the system combines endurance with flexibility. The vehicle runs on a hybrid diesel-electric power system and moves using 6 electrically driven wheels. It can carry loads of up to 2,000 pounds and travel approximately 300 miles without refueling. When operating solely on battery power, it can move quietly for distances ranging between 7 and 12 miles, making it ideal for stealth operations. On internal fuel, the system can remain active for nearly 120 hours, and it can generate up to 15 kilowatts of electrical power to support other equipment in the field. Its top operational speed is around 10 miles per hour, but it can be towed at significantly higher speeds when necessary. Remote control functionality extends to nearly 2,000 feet, and the system can operate for a full day on a single battery charge. Its low profile allows it to follow troops on foot or maneuver through narrow paths and confined spaces. Each wheel is powered by its own electric motor, enabling precise control and the ability to turn in place. The solid, airless wheels eliminate the risk of flat tires, increasing reliability in harsh environments. While the vehicle is in motion, the engine continuously recharges the batteries, removing the need for downtime. Another standout feature is its open architecture. The system is compatible with widely used robotic software platforms, making it easier to integrate new sensors, tools, or control systems over time. This adaptability ensures the vehicle can evolve alongside future mission requirements. Rapid deployment roadway system, mobility where roads don't exist. In military rescue, construction, and disaster response operations, traditional roads are not always available or usable. That's where the beam dispenser and portable roadway system comes into play. The system consists of aluminum roadway panels deployed using a steel beam attached to a loader via a quick hitch connection. Powered by the machine's hydraulic system, the dispenser can rapidly lay down stable driving surfaces in environments where conventional vehicles would otherwise be immobilized. The panels are engineered to perform in extreme temperatures, ranging from 40 degrees F to 140 degrees F, and most of the materials can be recovered and reused after the mission. Each panel is approximately 11 feet wide, with a working length of around 9 inches and weighs about 32 pounds. Panels connect using a male-female T-slot joint, allowing the roadway to flex slightly while maintaining structural integrity. Developed by Fawn Trackway, the system enables the movement, storage, deployment, and recovery of panels without manual handling. In practice, only 2 operators are needed, one to control the machine and another to guide panel placement. A full 131-foot roadway can be laid down in less than 3 minutes, dramatically improving mobility in challenging terrain. Military technologies that have reached a new level. From tactical awareness to precision control. Ultralight reconnaissance micro-aircraft, a flying set of eyes. At first glance, the numbers alone paint an impressive picture. Each micro-aircraft in the system weighs only about 2 ounces and measures close to 10 inches in length, with a single rotor spanning roughly 7 inches. Despite its compact size, it can reach speeds of up to 22 miles per hour and remain airborne for more than 30 minutes. Communication between the aircraft and its operator remains stable beyond 1 mile in open conditions. When the entire system is packed, including 2 aircraft units, a controller, batteries, and accessories, the total weight is approximately 3 pounds, making it highly portable for field teams. In real-world use, this aircraft functions like a small, intelligent flying camera, built specifically to provide rapid situational awareness. Its single-rotor design makes it behave more like a miniature helicopter than a traditional quadcopter drone. This allows it to hover steadily, move slowly when precision is required, and operate with relatively low noise, an important advantage when flying near buildings or sensitive locations. Imaging capabilities are surprisingly advanced for such a small platform. The aircraft carries a 12-megapixel daytime camera capable of recording 720p HD video and capturing high-resolution still images. Alongside this is a thermal imaging camera, allowing operators to detect heat signatures in low-light or obscured environments. Navigation relies on a combination of GPS, onboard vision sensors, automated flight paths, obstacle detection, and return-to-home functions. All data links are encrypted to protect sensitive information. When satellite signals become unreliable or unavailable, the aircraft does not simply lose control. Instead, it uses its onboard cameras and sensors to maintain position awareness, allowing continued operation. Automated flight modes can manage routes and basic decisions, but the operator always retains the ability to take manual control for closer inspection or unexpected situations. This balance between automation and human oversight makes the system both efficient and trustworthy. High-temperature breaching tool, instant access through steel. If you've ever watched science fiction films where doors are cut open with glowing blades, this next tool feels like it stepped directly out of that world. When activated, this breaching device generates temperatures exceeding 900 degrees F and releases a focused stream of molten metal for roughly 2 seconds. In that brief moment, the tool can punch a hole approximately 1/3 of an inch wide through 1/2 inch thick steel. The process relies on a thermite reaction, which instantly produces molten metal. This molten material is forced through a specially shaped nozzle and impacts the target with extreme heat and pressure. Unlike traditional cutting methods that slowly heat a surface, this tool melts through material almost immediately. Because the reaction does not depend on oxygen from the air, water does not significantly interfere with its performance. However, due to the short duration of the reaction, the tool is not intended for long cuts. Its purpose is rapid access, creating an opening through tough materials when time is critical. This capability is especially valuable in hostage rescue, forced entry, or emergency response scenarios where seconds matter and traditional cutting tools would be too slow or dangerous. Spear systems, from ground firepower to electronic warfare. The name Spear can be misleading because it refers to two very different military systems developed by the same company. The first is a 120 mortar system designed for ground forces. This weapon can strike targets at distances of approximately 6 miles. What truly sets it apart is its soft recoil system. Normally, firing a mortar of this size would place enormous stress on a vehicle. However, the recoil absorption system reduces the impact enough that the mortar can be mounted on lighter 4x4 vehicles rather than heavy armored platforms. This design choice significantly improves mobility and deployment speed. A small crew of just 2 operators can manage the entire system. Built-in navigation and fire control allow the crew to stop, fire, and relocate quickly, reducing exposure to enemy detection or counterfire. The second Spear system operates in an entirely different domain, electronic warfare. Mounted on aircraft, this version is designed to disrupt and confuse enemy radar systems. It continuously scans for hostile signals and uses digital radio frequency memory technology to replicate and manipulate those signals, effectively deceiving enemy sensors. Rather than destroying targets, electronic spear systems win battles invisibly by denying the enemy reliable situational awareness. MAV'RX Armored Vehicle, a new take on heavy mobility. Unveiled at the International Defense Industry Exhibition in France, the MAV'RX Armored Vehicle has been widely described as a glimpse into the future of armored mobility. Although still a prototype, it has already drawn significant attention from defense analysts. This massive 4x4 armored vehicle measures approximately 23 feet in length and weighs close to 21 tons. Its true strength lies in its ability to traverse extremely challenging terrain. The vehicle is capable of climbing steep inclines and fording water depths of nearly 4 feet, allowing it to operate in environments that would stop most wheeled vehicles. Developed by MAV'RX, the MAV'RX was designed in response to the evolving nature of modern battlefields. It occupies a middle ground more protected than a standard patrol vehicle, yet faster and more agile than a traditional tank. Crew safety is a central focus. The welded steel hull meets high-level NATO protection standards, and the interior includes blast-absorbing seats and advanced air filtration systems. The vehicle can carry up to 10 personnel, with the driver and commander positioned at the front and 8 troops seated in the rear. Side doors and a rear ramp allow for rapid entry and exit during combat situations. Realistic training ammunition, bridging practice and combat. Training realism has long been a challenge for military and law enforcement units. This system offers a powerful solution by allowing personnel to train with their actual service weapons while using specialized, non-lethal ammunition. Instead of traditional rounds, the system uses reduced energy cartridges with plastic projectiles. These rounds travel fast enough to feel realistic and deliver a noticeable sting upon impact, but they are not lethal. Available in standard calibers such as 9, they require only minor internal modifications to the weapon. What makes this approach superior to airsoft or laser-based training is authenticity. The trigger pull remains the same. The slide cycles normally. Recoil and sound are preserved. When a participant is hit, there is a real physical sensation, often accompanied by a visible mark from a colored detergent-filled projectile. This realism changes behavior. Trainees move differently, take cover more seriously, and make better decisions under pressure. The system creates a stress environment that closely mirrors real-world encounters without the risks of live ammunition. Multi-tube electronic launcher, rapid non-lethal effects. This system uses 37 electronically fired tubes arranged into modular clusters, allowing operators to deploy multiple effects quickly and precisely. Each sealed cartridge measures about 9 inches long, ensuring reliable performance even in rain or high winds. Depending on the munition type and mounting height, effects can reach distances between 165 and 525 feet. Available cartridges include flash elements that create intense bursts of light and sound, smoke rounds that obscure visibility for 20 to 40 seconds, and combined smoke irritant options that add a physical discomfort element. From the operator's perspective, the system functions more like a digital control panel than a traditional launcher. Each tube is fired electronically, enabling precise timing and sequencing. The launcher can be mounted on vehicles, tripods, ballistic shields, or fixed defensive positions, and configurations range from compact groupings to large 30-tube arrays. XM204 Intelligent Mine System, Precision over Randomness. The XM204 stands out as a new generation of intelligent, controlled mine systems. Shaped like a compact suitcase, it contains 4 submunitions and can monitor targets within a 1-kilometer radius. Unlike traditional mines, the XM204 does not detonate immediately upon detecting movement. Instead, its onboard processor analyzes movement patterns to distinguish between random noise and actual heavy-wheeled vehicles. This discrimination reduces unintended activation and improves target accuracy. Once a valid target is confirmed, a submunition is launched upward. It then uses its own sensors to track the vehicle before descending and detonating from above, where armor is typically weakest. The system includes safety features such as visual indicators showing whether it is armed or safe. If no target enters the area within a set time, the system automatically shuts down. Weighing approximately 38 kilograms, it is portable enough for 2 soldiers to carry. Operators can also program self-destruction intervals ranging from 4 hours to 15 days. Military technologies that have reached a new level. Automation, precision firepower, and intelligent defense. Fully automated artillery vehicle, firepower that moves fast. This next system represents the evolution of traditional artillery into a highly mobile, automated weapons platform. Built on a heavy-duty truck chassis, it combines an 8x8 wheeled vehicle with a fully automated 155 artillery gun, creating a powerful yet flexible long-range fire system. The vehicle weighs nearly 32 tons and stretches approximately 43 feet in length, making it an imposing presence on the battlefield. Power comes from a 402 horsepower diesel engine that drives all 8 wheels, allowing it to reach highway-capable speeds on paved roads while still maintaining controlled mobility off-road. With a range of roughly 370 miles, the system can relocate over long distances without the need for constant resupply. Its main gun fires standard NATO 155 ammunition, giving it compatibility with existing supply chains. The gun can elevate for indirect fire or lower slightly when needed, and it can rotate 60 degrees to either side without repositioning the entire vehicle. Using base bleed or extended range shells, the system can strike targets beyond 24 miles. Mobility remains a key strength. The chassis is designed to handle water crossings close to 4 feet deep, wide trenches, and tall obstacles that would stop many wheeled platforms. Inside the armored and sealed cabin, only 2 crew members are required, a driver and a commander. Most gun operations, including loading, aiming, and firing, are handled electronically. The cabin is pressurized and filtered to protect against nuclear, biological, and chemical threats, while climate control systems support long-duration missions. An auxiliary hydraulic power unit allows the artillery system to operate even when the main engine is shut down, reducing noise and thermal signature. Advanced fire control software manages ballistic calculations, diagnostics, ammunition tracking, and firing modes. The system can deliver single shots, timed barrages, or simultaneous impact fire, where multiple rounds strike the target at the same time. The goal is simple: fire quickly, relocate immediately, and avoid counter-battery fire. Reconnaissance and demining robot, precision in dangerous ground. This compact robotic system is designed to handle reconnaissance and explosive hazard removal simultaneously. One of its most valuable components is its articulated robotic arm, which provides both strength and precision. The robot weighs around 30 pounds when fully equipped with batteries in the arm. Its compact body fits within a footprint of roughly 9 by 28 inches, making it easy to transport and deploy. On open terrain, it can move at speeds of up to 6 miles per hour, and its track system allows it to turn in place, navigate debris, and operate in confined spaces. The robotic arm can lift heavier objects when positioned close to the body and still manipulate lighter items when extended outward by approximately 2 feet. Because the arm can rotate a full 360 degrees, the robot can interact with objects from multiple angles without repositioning its base. Battery power supports several hours of operation depending on task intensity. During missions, a multi-camera system provides the operator with a clear view of the environment. 4-color cameras deliver overlapping perspectives, while an optional thermal camera highlights heat differences when visibility is limited. Control is handled through a touchscreen tablet interface that feels intuitive to anyone familiar with modern mobile devices. A robust radio communication system maintains a strong link between the operator and the robot, even inside buildings or underground environments. This makes it particularly useful for clearing explosives, inspecting suspicious objects, or scouting hazardous locations before personnel enter. Anti-drone capture system, neutralizing threats without destruction. As small drones become more common, controlling restricted airspace has grown increasingly complex. This system addresses that challenge by capturing unauthorized drones intact rather than destroying them. The system uses a combination of compressed air launchers, smart tracking software, and deployable nets. It can engage small multi-rotor drones and light fixed-wing UAVs at distances of up to approximately 820 feet. When activated, the system fires a projectile that has been pre-programmed with flight data. As it approaches the target, a net deploys at a precisely calculated moment, wrapping around the drone's propellers or wings. A parachute then opens, slowing the descent so the captured drone lands with minimal impact. This approach offers a significant advantage. The drone remains largely intact. Investigators can later analyze onboard electronics, cameras, payloads, and stored data to determine who operated the drone and for what purpose. Developed by OpenWorks under the name Skywall Auto, the system can operate independently using its own cameras and AI-based vision, or integrate with existing radar and command systems. By avoiding radio jamming, it reduces interference with friendly communications and minimizes unintended side effects. Altius Loitering Munition Family, Observation and Precision Strike. The Altius family represents a class of systems often referred to in the media as kamikaze drones, though their actual capabilities extend far beyond that label. Each unit launches from a compact tube and deploys its wings and tail automatically upon exit. The aircraft measures approximately 3 feet in length with a wingspan of just over 8 feet and weighs about 27 pounds. Launch tubes can be mounted on ground vehicles, ships, or even other unmanned aircraft. Most launches use compressed air, which clears the aircraft from the tube without stressing its structure. Once airborne, onboard flight control systems manage navigation, altitude, and routing. Depending on configuration, Altius can fly nearly 270 miles, remain airborne for around 4 hours, cruise at approximately 37 miles per hour, and reach top speeds close to 56 miles per hour. The nose section can carry payloads weighing up to 7 pounds, allowing the system to switch between roles. Some versions are equipped with electro-optical or infrared sensors for surveillance, while others carry explosive payloads. This flexibility allows the aircraft to loiter over an area, observe activity, and strike a target only if authorized. That ability to delay engagement reduces collateral damage and improves decision-making. Clip-on thermal imaging optic, seeing through darkness and smoke. Understanding this next system requires a look at how it functions technically. It operates in the long-wave infrared spectrum between 8 and 12 micrometers, using an uncooled thermal sensor to detect subtle temperature differences. The optic provides a one-time base magnification with digital zoom options up to 4 times. Images are displayed on an internal screen and can be recorded as photos or video. Rather than replacing a standard daytime scope, this thermal unit mounts in front of it. This preserves the original optics alignment while allowing the user to switch to thermal imaging instantly. The result is a seamless transition between visible light and heat-based vision. Multiple display modes are available, including white hot, black hot, and color palettes, along with adjustable brightness, contrast, and polarity. The focus system compensates for temperature changes, keeping the image sharp across varying conditions. This capability proves invaluable when visibility is reduced by darkness, smoke, fog, or camouflage. Passive underwater listening buoy, intelligence without emission. This compact ocean-deployed device is designed to listen without revealing its presence. Once dropped into the water, it sinks to a pre-selected depth, either around 98 feet or as deep as 492 feet, and begins collecting sound data. Using a directional hydrophone array, the buoy listens across a wide frequency range, from low mechanical noises to higher sounds produced by propellers and water movement. Because it listens directionally, it can determine where a sound is coming from rather than simply detecting its existence. Collected data is transmitted via a one-way VHF radio link, using selectable channels to match receiving systems. The buoy does not wait for commands unless pre-programmed, reducing transmission risks. Operating time can be set between 30 minutes and 8 hours, after which the device shuts itself down automatically. Aerosmat Unmanned Ground Vehicle, robotic support for infantry. Developed in South Korea, Aerosmat is a light unmanned combat support vehicle that has drawn interest from the U.S. Department of Defense. Designed to move alongside soldiers, it quietly carries gear and supplies while reducing physical strain on personnel. The vehicle weighs about 4,000 pounds and can carry nearly 1,200 pounds of equipment. It runs on 6 electrically powered wheels and can reach speeds of 27 miles per hour on paved roads, slowing slightly off-road. A full battery charge supports travel distances of up to 62 miles, depending on terrain and load. Aerosmat can be driven remotely or operate autonomously using GPS routes and onboard sensors. Obstacle detection allows it to adjust its path without constant input. A follow mode enables it to track a designated soldier or vehicle automatically, maintaining formation. Passive infrared identification technology, recognition without light. This technology allows people and vehicles to be identified in complete darkness without visible illumination. It works by reflecting specific infrared wavelengths while remaining nearly invisible to the naked eye. There are no batteries involved. To human vision, the markers appear ordinary, but through night vision devices they become clearly visible. Small individual markers can be seen from several hundred yards, while larger vehicle markers are detectable from much greater distances. Applications include infrared patches on uniforms, helmets, and gear, as well as vehicle roof and side markings. Shapes, symbols, and thermal panels help reduce friendly fire incidents during night operations. Some versions glow briefly after exposure to light, enhancing recognition. Military technologies that have reached a new level. Protection, logistics, and the future of battlefield design. Military-grade backpacks built for decades of use. While high-tech weapons and vehicles often steal the spotlight, military operations rely just as heavily on rugged, reliable personal equipment. One such example is the modern military backpack, engineered to survive decades of hard use under extreme conditions. This pack is constructed from thick, abrasion-resistant fabric reinforced with heavy-duty webbing. The result is a structure that feels firm and stable even under heavy loads. Inside, a removable plastic frame sheet helps the pack maintain its shape and stand upright when fully loaded. Comfort and adjustability are essential. The shoulder straps are heavily padded, supported by an adjustable chest strap to distribute weight evenly. The hip belt accommodates waist sizes ranging from approximately 29 to 58 inches, allowing the pack to fit a wide range of users. Practical access is a standout feature. The main compartment opens from the top using a drawcord, but a long vertical zipper along the side allows users to reach gear stored at the bottom without unpacking everything. The lid includes a zippered pocket for small essentials such as keys or communication devices. Additional loops and attachment points on the front and bottom allow for carrying longer items like tools or poles. while side compression straps keep the load tight and prevent shifting during movement. When fully packed, the carry system feels supportive rather than soft, maintaining stability during long marches. At a price point around $254, it delivers durability and functionality without excessive cost. T4 medium-sized robot, precision handling in hazardous environments. The T4 robot is one of the most capable mid-sized robotic platforms currently in service. Designed to detect and neutralize chemical, biological, radiological, and explosive threats, it also plays a vital role in bomb disposal operations. The robot weighs approximately 154 pounds and runs on 6 batteries that provide more than 7 hours of continuous operation, depending on workload. Batteries can be swapped without powering the system down, ensuring minimal downtime during extended missions. With the robotic arm folded and cameras protected, the T4 measures about 36 inches in length. It can travel at speeds exceeding 5 miles per hour, climb stairs, navigate steep inclines, and handle side slopes greater than 30 degrees. It can also operate in water depths of up to 12 inches. Movement is handled by a tracked skid steer system, which provides excellent traction and control over rubble, stairs, and narrow passages. This places the T4 in a practical size range, large enough to lift and manipulate meaningful loads, yet compact enough to access confined spaces. The robotic arm is the heart of the system. Weighing roughly 72 pounds, it can extend 80 inches outward and 98 inches upward. Close to the body, it can lift loads up to 121 pounds and approximately 44 pounds when fully extended. Force-sensing gripper gives operators tactile feedback, allowing delicate manipulation of suspicious objects. A non-conductive wire cutter adds further versatility for explosive ordnance disposal tasks. Sonaflash Naval Sensor, Flexible Underwater Awareness. Sonaflash has attracted attention from the French Navy due to its compact size and adaptability. Once deployed from a patrol aircraft or helicopter, the device activates automatically upon water entry. Operating in the low-frequency range between 3 and 4 kHz, Sonaflash is optimized for long-range underwater sound propagation. The unit weighs about 35 pounds, stands nearly 3 feet tall, and measures roughly 4 inches wide. What sets Sonaflash apart is its dual-mode operation. In one mode, it functions purely as a passive listener, detecting sounds produced by submarines such as engines or mechanical movement. In the second mode, it actively emits a sound pulse and listens for returning echoes. This flexibility allows naval crews to respond dynamically to changing underwater conditions instead of committing to a single detection method from the outset. High-speed amphibious combat boat, speed meets shallow access. Speed and access define this advanced military vessel. Designed to operate in environments unreachable by conventional ships, the boat's twin-hull configuration provides stability while its carbon fiber construction keeps weight to a minimum. With a draft of just 3 feet, the vessel can navigate rivers, marshlands, and tight coastal zones. A small crew of around 5 personnel operates the boat, while space behind them accommodates 20 to 60 troops, depending on mission requirements. The rear deck supports loads of up to 10,000 pounds, making it suitable for vehicles, supplies, or equipment. Propulsion comes from 2 powerful diesel engines driving water jets instead of traditional propellers. Engine output varies by configuration, producing either 1,200 or 1,700 horsepower each. Weapons systems are remotely operated from inside the protected cabin. A common configuration includes a 30 automatic cannon, capable of tracking targets while the vessel is moving at speed. Some experimental versions have explored mounting a 105 gun for direct fire support. Crew protection focuses on shielding key areas from small arms fire, while integrated radar, GPS, radio, and network systems provide navigation and communication. In some configurations, small reconnaissance drones can be launched directly from the vessel to scout ahead. PL-01 Concept Light Tank, a glimpse of what could have been. The PL-01 Concept Light Tank debuted in 2013 and immediately drew global attention. Although development was halted in 2015, the design remains an important case study in modern armored vehicle innovation. Planned armament included either a 105 or 120 NATO standard gun, with reports suggesting around 16 ready rounds and additional ammunition stored internally. The firing rate was expected to reach 6 rounds per minute. Power was projected to come from a diesel engine producing nearly 940 horsepower, enabling road speeds of up to 45 miles per hour and a range close to 300 miles. Dimensions measured approximately 23 feet long, 12 feet wide, and 9 feet tall, with weight estimates ranging from 33 to 39 short tons, depending on armor configuration. Based heavily on the CV90 platform, the PL01 borrowed its suspension and mobility characteristics. The most distinctive feature, however, was its angular, flat-surfaced design intended to reduce detection. Heat management was also addressed through exhaust systems designed to diffuse thermal signatures. Origami-inspired ballistic barrier, folding protection in seconds. This innovative protective barrier blends materials science with origami-inspired engineering. Weighing around 55 pounds, the barrier is constructed from approximately 12 layers of Kevlar arranged in a Yoshimura fold pattern. Unlike traditional ballistic shields, this design contains no metal joints. Movement is achieved through controlled bending along the fold lines, allowing the barrier to collapse into a compact shape and then expand into a rigid wall in seconds. During testing, the barrier successfully stopped common handgun rounds, including 9, while remaining upright after impact. This is critical, as a barrier that collapses after being struck can expose those behind it. When deployed, the structure provides wider coverage than standard handheld shields, creating temporary ballistic cover similar to a mobile wall. One person can deploy it alone, making it useful in law enforcement and military scenarios where rapid protection is needed. The concept originated from engineering research at Brigham Young University, where researchers explored how origami patterns could solve real-world mechanical challenges. While initially developed for law enforcement, the design has clear applications wherever temporary ballistic protection is required. Heavy Vehicle Recovery Underlift System, power beneath the truck. The final system brings attention to logistics and recovery, often overlooked but absolutely essential components of military operations. This heavy-duty underlift recovery system is mounted on a multi-axle truck and designed to handle disabled or damaged vehicles. The underlift sits low to the ground and extends in 2 stages, allowing it to reach more than 13 feet from its mounting point. Hydraulic power is supplied through the truck's power takeoff system, enabling controlled lifting, pulling, and towing. Constructed from high-strength steel with a box-shaped boom, the system manages heavy loads efficiently. The boom can rise to an angle of approximately 25 degrees, providing the height needed for complex recovery operations. A rotating rope guide at the rear allows the winch cable to pull from different angles without repositioning the truck. Hydraulic cylinders provide smooth movement, while built-in load-holding valves keep the underlift stable under weight. When stabilizers are deployed, the system can lift extremely heavy vehicles. During transport, it can tow a wide range of disabled platforms, provided the truck configuration supports the load. Conclusion: technology as a force multiplier. Across every domain, land, air, sea, and subsurface, modern military technology is evolving toward a single goal: doing more while risking less. Robotics, automation, intelligent sensors, and advanced materials are redefining how operations are conducted. Rather than replacing humans, these systems extend human capability. They enter danger first, carry the heaviest burdens, provide clarity in chaos, and buy time when seconds matter most. From origami-inspired ballistic walls to autonomous artillery, the future of military technology is not just more powerful, it is smarter, safer, and more adaptive.